Okay, so quadratic formula. We should be familiar with quadratic formula. And some of you might have a song. I didn't even know a song existed until I started teaching, and I had people singing it. So, I don't know. If you sing it, whatever. Quadratic formula. It reads, we can use a technique of completing the square to derive a formula for the roots in general of the quadratic equation. Okay. Now, here's the thing about the quadratic equation. It is such a well-known formula. Okay. We use it all the time. And you would think that something like something this big might have somebody's name attached to it, right? You might think that it could be called Euler's formula, even though there isn't Euler's formula, or something like that. Okay. Well, when I first took college algebra, I'm pretty sure we're introduced to this definitely in high school, but I guess I thought about this in high school or in college. I would think, okay, so this quadratic formula, it is, for all intents and purposes, pretty complex. And I'm thinking, okay, so did some mathematician sit in a corner a long, long time ago with his little candle and just start plugging in b's and square roots and all sorts of stuff to eventually figure out how in the world to get this quadratic formula? And then once they did come up with something, they had to plug in equations to see if it worked. Okay. And again, this is how my mind worked, and it might be how your mind works right now. But that's not the case at all, and I'm gonna show you that here in a moment. Okay. So the reason why there's no name attached to the quadratic formula is because it is so easy to derive that I'm pretty sure a million mathematicians figured it out all at once. So let's do it together. We're going to be mathematicians for a few minutes. Okay. So our quadratic equation is ax squared plus bx plus c is equal to 0. Okay, we're going to do the completing the square, and I told you before that I need to have a 1 in front of the x squared, right? So I'm going to divide this entire problem by a. So by doing that, I'm going to go x squared plus b over a x plus c over a is equal to 0. Okay, well, I'm going to continue my completing the square process here. So I'm going to move the c over a over to the right, so it's going to be negative c over a. Okay, so I'm only moving the c over a because that's the constant. Okay, because the b over a, well, that's connected to the x, so I can't just move that by itself. Right. Well, let's go through here and let's make our algorithm. All right, we said it was b halves quantity squared. Step 1, we're going to substitute that b value in. Step 2, we're going to divide by 2. Step 3, we'll square. Okay, these 3's aren't happening, are they? Okay, there we go. Hey, that's a good looking 3. Anyways, so b over a is my, b value essentially. Okay, it's the constant in front of the x. So we're going to put b over a right there. Okay, well, what is b divided by a divided by 2? Oh, that's actually a good segue here. So what is b over a over 2? Okay, now it's not just you guys. I have calculus students, because they're summer vacation, Christmas break, whatever. There's a lot of things in between that you just kind of forget stuff if you don't care about it, right? Or if you don't use it, you lose it. Well, if recall that something like this is just b over a divided by 2. Now it becomes really easy to what we're doing, huh? We got b over a times, we flip it. Okay, so it just becomes b over 2a. Does that make sense? So looking at something like this, it does look kind of daunting, but if you just recall that it's just a, use your division sign and then flip, multiply and flip, then it's not that bad. So let's do that. So we're going to have, hold on, do we do it in green? I don't know. So we're going to have b over 2a. All right, well, b over 2a, I square it, so it becomes b squared over 4a squared. Okay, so if you recall, step 3 is what I add to both sides, right? So let's go ahead and do that. And then plus b squared over 4a squared. And that's equal to a negative c over a, and then I also add that to the right side, right? So plus b squared over 4a squared. Okay, well, if you recall, step 2 over on the right in green, well, that's just what I plug in to make it a perfect square binomial. So I'm going to have x, and in the green, again, I'm color coordinated again, so x plus b over 2a quantity squared. Okay, now the right side. The right side, it requires a little bit of manipulation, okay? But it's manipulation that you should be aware of. If I want to add two fractions, what do I need to have, okay? I need to have a common denominator, right? So let's snip this out. Okay, that's not actually, okay. Can I just move it? Okay, I don't know if I can just move it. Okay, anyways, so what I'm going to do here is I'm going to look at this, and I need to get a denominator of 4a squared, right? So what I'm going to do to this equation is multiply the top and the bottom by 4a. So let me see here. Let me erase this and really show it. So we're going to multiply the top and the bottom by 4a. And then, of course, over here we said we added what? B squared over 4a squared. Okay, so all I'm doing right here, right there, right? All I'm doing to that c, negative c over a, is I'm just multiplying it by 1. So I'm not changing its value at all, right? 4a over 4a is just 1. So I'm multiplying by 1. It's okay. I'm allowed to do that, okay? So once I do that, this equation becomes 4ac, I'm sorry, negative 4ac, all over 4a squared. And then that we have here is b squared over 4a squared. And now we have a common denominator, and that's exactly what I'm looking for. So let's, oh, we're going to have to snip again, aren't we? Okay. All right, so we're going to snip this and proceed on the next slide. Okay. All right, so once we have this, we're going to just rewrite the left side. So x plus b over 2a quantity squared. Now the right side, I need to have that common denominator, so now I can just combine my numerator, right? So it's going to have negative 4ac plus b squared all over 4a squared. All right, if you're bored to tears, sorry, bear with me. All right, at this point, now I need to square both sides. So by doing such, I've got x plus b over 2a is equal to plus or minus the square root of, now that numerator is negative 4ac plus b squared, okay? Well, now I know I could write that as what? B squared minus 4ac. And now everything should be coming together, huh? Over 4a squared, okay? Well, what is the square? We can split this up rather as plus or minus the square root of b squared minus 4ac over the square root of 4a squared, which we know can be plus or minus the square root of b squared minus 4ac. And then what's the square root of 4a squared? Well, the square root of 4 is 2, and the square root of a squared is a, so 2a. Okay, and now what we're going to do is we're going to subtract b over 2a right here from both sides. So we're going to have x is equal to, we're going to subtract b over 2a, so it's going to be minus b over 2a, and it's going to be plus or minus the square root of b squared minus 4ac all over 2a. And similar to what we did above, once we have a common denominator, so we can just combine the numerators, right? So this becomes x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? And that's it. That's the quadratic formula. We can derive the quadratic formula by just taking the definition of a quadratic equation and completing the square. Now, I'm just going to venture to say that every one of you didn't really care to do that, but we did it anyways. Okay. Example 3, using the quadratic formula. Let's see here. How far does this go? Okay. So we're going to skip to using the quadratic formula because I feel like that's something that you have done ad nauseum. And you will have plenty of practice leading into this in your homework. I will provide the solutions though. Actually, you know what? I'm going to make you look up the solutions in the textbook because I want you to look at the textbook. Next up, we're going to talk about the discriminant. Okay, so the discriminant. Let's do this. We'll do this. Okay, we'll uncover that here in a moment, but I just want to show that we can derive these definitions on our own. Okay, so reading up here, it says the discriminant. The quantity b squared minus 4ac that appears under the square root sign of the quadratic formula is called the discriminant. Okay, so b squared minus 4ac, if we look, ooh, that's not what I wanted. Here, and of course, it was also in the example I did, but this looks a lot nicer and neater. The b squared minus 4ac that we see there in the numerator of the quadratic formula. So let's do just a little bit of thinking here, okay? So looking down here now, where I marked it out, again, just thinking about the b squared minus 4ac inside the square root, okay? So b squared minus 4ac inside the square root, okay? So d would be the discriminant. So if b squared minus 4ac in the discriminant, okay, if it were greater than 0, okay, so if it were greater than 0, then it would come out to be some number, correct? So we would have negative b plus or minus the square root of some number. Doesn't matter, all right? But it's gonna equal to some number. We'll just call it we'll call it m. All right, and then of course it's all over 2a. All right. Well, so if we have a negative number plus or minus some number all over 2a, which would be some number. So we're basically having some number plus or minus some number over some number. So that means that we would have two solutions, right? We would have negative b plus some number over 2a and negative b minus some number over 2a, okay? So we'd have two real solutions, right? Okay, now what if d is equal to 0? So what if the discriminant was equal to 0? Okay, well let's imagine that. So we've got negative b plus or minus. All right, the discriminant would be 0, right? So if the discriminant is 0, we've got square root of 0, correct? So it just becomes negative b plus or minus 0, or in other words, just simply negative b over 2a. Okay, so if the discriminant was 0, well then we would have one real solution. Okay, well now let's go back the other way here. And now let's say that d is less than 0. Okay, so if we have a negative number, okay, not equal to 0 or not less than or equal to 0, because if it was equal to 0, we'd have just one solution. But if it was less than 0, we would have negative b plus or minus the square root of some negative number over 2a. Okay, well, what's the square root of some negative number, right? It's some imaginary number, it's some complex number, right? So we would have negative b, that's an eraser, Sherman, negative, still an eraser, negative b plus or minus, some imaginary number over 2a. So we'd have negative b plus I over 2a, and then negative b minus I over 2a. Or in other words, we would have no real solution or two imaginary solutions. Okay, so that would be the discriminant. Let's see here. Don't need that. And this example just wants us to find out how many real solutions each equation has. And this would just be another one of those where I don't even solve. It's just something you can read. I mean, we'll read together, but something you can read on later instead of me working it. So use the discriminant to determine how many real solutions each equation has. Okay, so we look at a, we got x squared plus 4x minus 1. So it's b squared minus 4ac, right? So we would say b squared, so it's 4 squared, minus 4 times a, which is 1, times c, which is negative 1. That's all we're doing. We're just plugging in b squared minus 4ac. All right, well, it's equal to 20, so that is greater than 0, so we have two real solutions. All right, for b here, if we substitute it in, we got b squared, so negative 12 squared is 144, right? Minus 4 times a times c, well, 144 minus 144, well, that's 0. So we're going to have one real solution. And of course, following in line here, we take the b squared minus 4ac, we end up with a negative number, and that negative number tells us that we have no real solution. Okay. All right, so I got 5 minutes left, so that's good. And we messed up the open boards for a moment. That concludes our lecture. This will be part 2.